Hello, welcome everybody. I'm going to begin your notes on 8.4 trigonometry. Trigonometry is a very broad topic, but I'm going to only cover some of the basics to get you started. We've been talking in class over the last few days about Sohcahtoa. So I do want to talk about what is Sohcahtoa and how do you apply it. So we will begin a discussion with there. I did kind of mention briefly that S represents sine. Sine is spelled S-I-N-E, but it's often abbreviated as sin. But don't ever say sin, because it really, even looking like this, S-I-N, is pronounced sine. And then I'm going to put a symbol here. This symbol is theta. It's a Greek symbol that often means an angle measure. So instead of using x for an angle, x is usually denoted for sides, we're going to use this Greek symbol, which is a circle with a line through it, and it's called theta, T-H-E-T-A. Okay, theta. So sine of theta is equal to the opposite side divided by the hypotenuse side. That's where the S-O-H comes from. And then cosine of an angle, so instead of writing C-O-S-I-N-E, which is cosine, it's often abbreviated as C-O-S, but it's still pronounced cosine of an angle. That equals A divided by H. So A is adjacent side and H is the hypotenuse, abbreviating these. And tangent, of course, T-A-N-G-E-N-T, that's tangent, but often abbreviated with T-A-N, but still pronounced tangent, not tan. Tangent of an angle is equal to the opposite over the adjacent. These ratios are always true, so we have a little memorization tool called Sohcahtoa. So what's the purpose of this? The purpose of this is oftentimes you're not able to measure three sides of a triangle. For example, if this is a building here, and I knew how far away I was standing from the building, and I also knew the angle from the ground up until the top floor of the building, I could then figure out how tall the building was. So even though I can't go and drop a measuring device from the top of the building, as long as I know the angle measurement here and how far away I am, I'm able to figure out different lengths of triangles. So that's its major purpose. Another major purpose is sometimes we want to know this angle because maybe we have a laser pointing up here, we're trying to shoot a rocket or something at a certain angle, and we just need to figure out that angle. We could also use trigonometry to do that, but that's for later. But basically it finds missing sides and angles. So here's what I had on the last slide, so I don't know if you need to repeat this, but basically let's concentrate on cosine. And this is exactly what I had on the last slide. And then this little fraction here, the A over H, that's where the K comes from. And this for tangent is the toa. And this here is the Sohcahtoa. And before you begin any of these problems, you do have to have an understanding of which sides are opposites, adjacents, and hypotenuses. And that all depends on your angle. We talked about this in class. So if I'm referring to angle A, or if I know angle A, then this side over here is the opposite, and this one's the adjacent. But yet, if I flip it around to angle B, then the opposite and adjacent gets flipped. So the adjacent now goes to this side where it was opposite, and this becomes my opposite side because opposite means across from. So this is like perspective from angle A and perspective from angle B. You're never ever going to use the perspective from the right angle because the right angle you can call this the hypotenuse, but then what do you call opposite and adjacent? It just doesn't make any sense. So before we begin, we're going to put the first letter here, alphabetized A. I'm going to circle that. QRS, I'm going to circle the Q. And WXY, I'm going to circle the W. So this little activity here is just naming O's, H's, and A's for opposite, hypotenuse, and adjacents. So why don't you do that really quickly and draw these pictures, pause the video, and then I'll give you the answer in a moment to see if you're correct. The easiest one to always identify is the hypotenuse. So that's across from the right angle, or the longest one. Then the opposites, in my opinion, are the next easiest one to identify. If this is the angle that I'm referring to, A, then this would be opposite. Therefore, this would be adjacent. If this is the angle I'm referring to in the second triangle, then this is opposite across from, this is next to or adjacent. And if this was my angle I'm referring to, this is my opposite, this is my adjacent. Without being able to do this, you're going to really struggle. And then just don't forget that if I refer to the other angle like B, then these two guys just get swapped. Now, there's a couple things that I'm going to want you to do. There's 3 learning targets for this chapter. One of them is to identify ratios, which mean fractions. You're going to just be working and kind of figuring out how to write these as fractions or ratios. And this is just our good old Sohcahtoa. So let's do the signs. So the sine of n, I'm starting with this angle as my reference angle. So this is my hypotenuse always, this is my opposite, and this is my adjacent. So sine is equal to so opposite over hypotenuse. So the fraction I'm going to use is the length of the opposite, which is 9, and the hypotenuse, which is 15. So 9/15. If you think you got the hang of it, feel free to pause the video. If you need a little explanation, I'll move on. Cosine is adjacent over hypotenuse. So that would be adjacent is 12, hypotenuse is 15. So these sides have, these sides have a ratio of 12 to 15. Wrong one. Let's erase that really quickly. And this would be 12 on the top and 15 on the bottom. And then tangent is toa, opposite over adjacent. So the opposite is 9, the adjacent is 12. I'm going to move to a different color blue over here for these guys because now my reference angle is L. So the hypotenuse stays. This is now my opposite and this is my adjacent. So when I'm doing L, for sine it's so again. So O is 12. Hypotenuse is 15. And for cosine, it becomes 9 over 15. And for tangent, it now becomes opposite is 12, adjacent is 9. And you can kind of identify patterns here. For example, the cosine of one angle is the same as the sine of the other, and the sine of one angle is the same as the cosine of the other, and tangent just gets reciprocaled when you're talking about different angles in one triangle. Now my last question here is a problem-solving tool, and you can't really see my calculator and what I'm doing off of my screen, but I will explain it to you verbally. If I need to find x and y in this picture, and I know an angle and a side, it doesn't matter which side I know, 10 degrees and 16 degrees, I can then use trig to find x and y. So I'm going to start with x. I'm going to circle this in red. And I'm going to circle this in red. The one that I know is the hypotenuse, the one that I'm trying to find first. I have to do these separately. The one I'm trying to find first is x, and that is the opposite side that the angle is. Now if I look at my Sohcahtoa, you need to determine which one of these 3 to use. Because I'm looking for opposite, and I have hypotenuse, I choose to pick sine as my proper trig function to use because that's the O and the H one, the O and the H. The one I have and the one I need. So I set it up as sine of the degree measure, which is 10 degrees, equals a fraction. My fraction is opposites on the top, which is x, hypotenuse on the bottom, which is 16. Now here's where you're not going to be able to see my calculator. So I'm using my calculator right now and I'm typing in the sine of 10. The decimal answer I get is 0.1736. I would suggest you use 4 decimal places for these problems. So I have used my calculator and done a conversion. If you remember correctly, when we did the Google spreadsheet, we all got around this value for sines of 10 degrees. Now you just have to find x. So it'd be like cross multiplying. If you want to put this over 1, you can, but basically all you have to do is multiply this by 16 to cancel this. So you multiply this by 16. So I take that number, 16, and multiply it by 0.1736. And I get x equals 2.778. Then I need to find y, so that involves me doing a completely separate math problem. Once again, I'm using the 10 degrees. So the question is it sine of 10, cosine of 10, or tangent of 10? Well, you have to figure out what you have, which is the hypotenuse again, so that eliminates tangent, because tangent doesn't have an h in it. And then the one I'm trying to find now from the 10's perspective is the adjacent. So now I'm going to use cosine. That's how you determine which of the 3 trig functions to use. Set up your fraction, which is adjacent the y, hypotenuse the 16. Once again, I moved my calculator and I type in cosine of 10. The cosine of 10 is 0.9848. I'd suggest 4 decimal places if you do that. By the way, if your calculator produces this kind of answer, negative 0.839, that means your calculator is in radian mode, and we need to fix that. You need to get it into degree mode because we're dealing with degree measurements. So if you don't understand what that means, I can help you in class. But hopefully you type in cosine of 10 or 10 cosine, depending on your calculator, and you get this 0.9848 answer. Once again, you cross multiply or multiply both sides by 16. And you take 16 times the 0.9848, and you get 15.75. That is how you find your y. Sometimes you won't be given the hypotenuse, and you might be given the adjacent or the opposite, and tangent does come into play. It only didn't come into play on this specific problem. Hope this gets you started. Good luck. Thanks for listening.